everyone, so today we'll be discussing a question which is a past year question for physics. First of all, let's read through the question. Figure 7 shows a 15 kg of load held in equilibrium by roots P and Q fastened to the ceiling and the wall respectively. So let's highlight out the keywords. 15 kg of load. This is actually the mass of the object. However, we'll be using the weight afterwards, so might as well we can just convert it now. So weight equals to mass times gravitational acceleration, which is 15 times 9.81 equals to 147.15 Newton. The next one is equilibrium. Equilibrium means that the sum of forces is equals to 0. There are two types of equilibrium. One is static, another one is dynamic. But for dynamic, it's for object that's moving in a constant velocity, which has nothing to do with our question today. So ours is static equilibrium, which means that this object is at rest. Thus, if this is not equal to 0, this formula will not be able to be used because the object will be accelerating to one direction. Okay, so after understanding the question, let's move to part A. Sketch a free body diagram at point O. To do this, we first need to label out the x-axis and the y-axis in a dotted line form. Let me change my color. Okay, first of all, we need to understand what is a free body diagram. It actually wants us to draw out the direction of each force and label them as well. So the center will be O. And then we move to the weight, which is a downward force. So we can draw a straight line downwards, label this as W. For P and Q, the forces are known as tension. So for Q, it will be a line moving to the right, and we'll label this as tension Q. And for P, as long as we can see a pattern like this using our mathematical knowledge, the angle here is the same as the angle here. So P will be a line to the left with an angle of 65 degrees. And label this as tension P. That's how we do this. Now let's move to the next part of the question. Calculate the tension of root P and Q. As I mentioned just now, equilibrium means that the sum of forces is equal to 0, and we can also break it into two parts, which is the sum of force in y direction is equal to 0, and the sum of force in x direction is equal to 0. To do this question, we need to recall back what we have learned in chapter 1.2, which is restoring vectors by using the trigonometry method. So for trigonometry method, first of all, we need to form a triangle. We use this part because there's an angle. So we label this as tension Py and tension Px. Okay. So the sum of forces in y direction includes the weight and tension Py. So let's label them as this. W plus tension Py is equals to 0. But for the weight, because it's moving downwards, so we'll have to put a negative in front, then substitute the value inside. So negative 147.15 plus tension P sine 65 degrees equals to 0. Move the negative in front. Tension P sine 65 will be equals to 147 plus 0.15. And just take your calculator and do some calculation. You will get the tension for root P is equals to 162.4 Newton, which is same as the answer here. Now let's move to finding the tension of root Q. Root Q is on the x-axis, so we'll be taking everything on the x-axis totaled up, and that will be equals to 0, which is tension Px plus tension Q equals to 0. just like the weight, because this tension Px is on the left hand side, so we'll have to add a negative sign at here as well. Then just substitute everything inside. Negative tension P cosine 65 plus tension Q will equals to 0. Substitute tension P in here. Negative 162.4 cosine 65 plus tension Q equals to 0. Then use your calculator, we will be able to get tension Q equals to 68.6 Newton. And that's how you can get the tension for root P and Q. I hope this video can help you, and thank you for watching. Bye bye.